Greetings and welcome, friends. Mr. Wadi here. We are in section 7.3, proving that a quadrilateral is a parallelogram. My friends in real life in here and I just were experimenting with kind of like how much information would I need about a quadrilateral to know that it's a parallelogram. And recall that a parallelogram, what is the definition of a parallelogram? Does anyone remember? No, you're giving me more. Those are some properties about parallelograms. It's a quadrilateral that has what? Yeah, opposite, two pairs of parallel sides, right? Well done. So that's the definition. And then yesterday we came to all sorts of conclusions about other facts within it, but by definition, it's just opposite sides parallel. So my goal today is going to be, can I, with the information given, prove that both pairs of opposite sides are parallel? That's going to mean I'm going to fall back on some of our, I think it was chapter 3 properties with parallel lines cut by a transversal, and use a bunch of those converses for us. So here we go. It says, given a parallelogram, you can use a parallelogram opposite sides theorem and parallelogram opposite side angles theorem, to prove statements about the sides and angles of the parallelogram. The converses of the theorems are stated below. You can use these and other theorems to prove that a quadrilateral with certain properties is a parallelogram. So here we go. So we've got theorems. Parallelogram, opposite sides, converse. And a converse is still a type of theorem, just so you're aware. Both pairs, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That's their claim. If that, then this, right? That's what they're saying, all right? And we just kind of experimented with that a little bit in Geometer Sketchpad. I guess I'll show my crazy sketch for our internet friends. Look at that. No matter how I move this, my adjacent or consecutive angles are supplementary. These consecutive angles are supplementary. Also notice that my the slopes of the sides are the same. And the way I defined this shape is I had two sides, and then the other sides were opposite sides were congruent to them. Oh, I just opened the wrong window. There we go, I think. All right, so there's the first one. How about this one? We haven't proven this yet. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. I think that one would be an easy one to prove. Actually, it's wonderful how elegant and brief some of these proofs are. I love it. I love it. Here we go. Let's prove this one. Here we go. Prove it together. We're proving friends. Heyo. So, given. All right. So I've got some given statements, as usual. Some things have to be assumed for me to prove anything. So we're starting with parallelogram, kind of the hypothesis of our statement. So, a quadrilateral with opposite sides congruent. All right, so there's given. What do you think I could do to prove this is a parallelogram? Now, it looks like they constructed a diagonal. That's a great idea. AC is reflexive. Okay, AC is congruent to CA. I'll flip it because these two triangles are rotated about one another. So I'll just figure out how to do that. I'm guessing that the direction you're going to go is proving that these two little triangles are congruent. And, yeah. Man, with the save. All right, here we go. So we're going to be able to say that triangle ABC, minus alphabetic order, is congruent to triangle CDA, right? CD was congruent to AB, so that's why those two letters had to go first. I like it. And as you said, side. Man, I just want some sides from KFC now. I really do. Oof, man. I used to order like 2 combo meals a day at KFC when I was doing construction, and I was just like burning crazy calories. My lunch would just be like, I'll have 2 of those combos, and then just like, was single-handedly genociding chickens, and I'm sorry. Sorry. But I built things. I might have had to use parallelograms, probably, because, yeah, you want to have rectangular walls, not parallelogram or walls only. So let's see. How is that going to help us from here? How am I going to prove parallelogramness? What are your guys' thoughts? I think we could say angle B. How do I know that? Is this going to help us, though? Oh, now I could say that, but that's actually, like, those two angles aren't going to help me prove parallelness. It would be a bit more work. I think it's possible. Oh. But I don't know that yet. I don't know that yet. I know that if this is a parallelogram, I know that those are congruent. I don't yet know that if those are both yeah, I can't prove parallelogram. Yeah. Exactly. Yes. Right. I know, it's like, it is weird, but it had to be proven true at some point before people knew it. So we're pretending that we're walking, like, we're just like, you might have like war reenactors. We're like reenacting the proofs that, you know, Euclid did 2,300 years ago. So friends, this is true, but I don't think that's going to be, I'm realizing that's not the direction that's going to help us. What will help us, how about this one? This angle and this angle are congruent. Yeah, I think so. I think this is going to help us more. What's the name for that angle, Lauren? This little guy. Not the full angle A, but the little one. Yeah, BAC is going to be congruent to angle... Actually, I wrote reflexive there. That is not at all the case. Guys, what am I doing? I got to pay attention to myself long enough here to get... Oh, dear. All right, here we go. This is my cheap way of, like, erasing. I just bury it behind a layer. The problem is it will erase to white and not to black. And so that's why I don't use it. And also, I don't want to have, like, my erase tool up on the screen. I'm trying to, like, you know, make it look crisp. Actually, I can hit tab and make my inkwell disappear. But I don't do that often either. So yeah, CPCTC. This is true but not helpful, but hey, it's there. And then as Lauren said, angle BAC is going to be congruent to angle DCA by CPCTC. All right, so those angles are congruent. I'll label those with a double arc. And then I think I could say that AB, yeah, is parallel to DC by alternate interior angles what? Converse. That's right. If I know the angles are congruent, then I can prove the lines parallel. That's a converse. All right, and then I think by similar logic, I'd be able to say this guy and this angle are congruent. Who can give me the names of those triple arc angles that I just labeled? Let's see, I just cropped our letters. So, CAD, okay, CAD. I'm a fan of computer-aided design. And ACB, sure. And CPCTC is why that's true. And then I can prove that these are parallel using similar logic. BC is parallel to the AD. I like it. And the reason, alternate interior angles converse. And now that I've proven opposite sides parallel, I think I can say that ABCD is a question, comment? Oh, man. Guys, I don't know. I'm just like terrible at my job today. But you guys are here to save me. We're a team. Let's see. Can I like erase just what I need there? Man, with the save. There we go. Congruent. Parallelo. And that's true by def of parallelo. All right. Whew. Wow. That was a lot of work. All right. Oh, guys, I'm afraid of this example one already, because... I'm sorry, I wish my print screen option didn't fade the screen. I know how to do that with Microsoft snipping tool, but my, what is it, light screen, Lightcast? I downloaded some app that's better, but... Yeah, it's, called the snipping tool. You can, like... Yeah, there we go. Yeah, that is an area where, I'll be honest, Macs have a better screen capture series of commands and hotkeys than PC. Just being honest. I like PC for a lot of other reasons, though. But we won't start that war today. Don't need my comments to go all crazy. All right. Oh, there we go. That's not what I wanted. All right, I'm going to use... What is the name of my other app here? Light Shot is the name of this one that does this. It's a little bit quicker for me, but... It takes screenshots of a portion of the screen. Like, if I click it and then drag, I can then, like, save it, I can print it, I can, like, apparently send it... But I just hit the copy to clipboard. I don't know, you can do all sorts of things. Nah. So... All right, guys, I'm scared of this ride already. My stomach gets all queasy if I go on a swing. And then I walk to work for 4 years of my life, and then now, like, if I go over Route 9 and my wife is driving, I'm getting car sick. Like, it's crazy. I don't know. I'm already nauseous just looking at this picture. It says an amusement park ride has a moving platform attached to 4 swinging arms, and these arms are congruent to each other. Those are both 16 feet by def of Kong. They're congruent. All right. DC is parallel to the ground line. Okay, I like that. Explain why the moving platform is always parallel to the ground. Well, if this is 38 for that distance and that's 38 for that distance, those are congruent by def of Kong. And then I would say that ABCD is a parallelo. Are you guys good over there? Oh, I'm sorry. It's a parallelo. Why is it a parallelogram? Because parallelogram, opposite side, congruence, converse. Right? And if this is a parallelogram, then I know that this is parallel to DC by def of parallelo. And Lauren, didn't we have like a parallel lines transitivity or something? I think so. AB is going to be then parallel to L. And I'll just say parallel lines transitivity. It was something like that. You guys all know what I'm talking about. You know. All right, let's, ooh. Then here's the classic of throwing some algebra in the geometry. I didn't quite hear what was said. Throw in a biscuit. Oh, I don't know, there's a song. What? Man, I don't watch commercials anymore. Actually, I just tried out a week of Sling TV. I wasn't that impressed, but Sling TV does like live TV over the internet, and my son was up watching it, and my 5-year-old's like, commercials are the worst. No. Yeah, I'm still recording. But yeah, so in case you were wondering, Everett's official opinion on commercials is that they're the worst. So here we go. It says, what values of x and y is quadrilateral PQRS a parallelogram? Well, if these sides were congruent, then I'd be able to say that it's a parallelogram. What values would those be congruent? Well, I could say that 2x minus 1, when that is equal to x plus 9, that would be helpful to us. What's another equation I could write? Oh, you're solving it already? Okay, we can solve this first equation. No. X equals 9. X equals 10. All right. So x equals 10. How do I find y? So x plus, or y, I'll write y equals x plus 7. And then, ooh, here we go. Substitution. I love substitution. There we go. We'll have y equals, yeah, we're so close to a long weekend. It's great. So y equals 17, like so. All right, so those are the values of x and y that would make those opposite sides congruent, and therefore the quadrilateral would be a parallelogram. All right, let's take a look at another example here. Ooh, a couple more theorems, friends. Oh, you actually definitely want this. This last theorem is going to be so helpful. So helpful. It's such a strong theorem, especially when because we are also going to prove today, Lauren, we're also going to prove today that quadrilaterals are parallelograms on the coordinate plane, and you absolutely want this theorem to do that, because this will be so much easier. It'll save you so much time. Yeah, let's see. Opposite sides parallel and congruent. So if I have congruence and parallel, is the only way for these other two sides to be drawn such that they would be parallel. That is an interesting one. I like it. And it turns out it is sufficient information to prove that it's a parallelogram. And then also we have the parallelogram diagonals converse, that if you have two lines that bisect each other, if you connect their endpoints, that those new segments will be not just a quadrilateral, but a parallelogram, right? So once you know these, it's not that bad. Ooh, look at this. This person's bad at construction. Oh man. Snipping tool, I'm not impressed. Yeah, Microsoft. I heard Microsoft actually just added to Windows 10 the ability to stream from the operating system. No, from on Windows 10. Like, so like I use OBS, but like now that they're building streaming from your operating system, that's kind of nice. It's just becoming even more. And then I also heard that like at Toys R Us, you can get like buy a kit for like streaming. Like, so like if you're a kid and you wanted to like do Lego reviews, you could go to Toys R Us, buy a box of Legos, buy this streaming kit, and then like make your own YouTube video as like you review your Legos. Be pretty amazing. I'm good. Actually, isn't Linux made by Finns? I might be wrong. 4 minutes. I think yeah, you're right. It is 4 minutes. I was thinking we had till 40 past. You're right. Thanks, Eliza. You got to keep me on track here. All right. The doorway shown is part of a building in England. We're assuming that's true. That was given information. All right. Crazy England. Over time, the building has leaned sideways. And so I'm assuming they had to construct new doors, or they've had to chop off the top and bottom of the door to maintain opening and closing ability. All right. Explain how you know that SV is equal to TU. Well, okay. So opposite sides, parallel and congruent theorem. Therefore, this is a parallelogram. Right? So opposite sides, parallel and congruent theorem. So that's a parallelogram, but then how do I know that these are equal to each other? SV is congruent to who now? Why are these congruent? No. It was parallelogram opposite sides congruence theorem, right? So if once I knew it was a parallelogram, then I could, be able to do that. Let's see. let me just, here we go. Get this little summary chart up here. Man, snipping tool, you are the worst. It gives me so much ghosting, and I don't know why. All right. So guys, here we go. Here's a concept summary. Here's a bunch of ways to prove that things are parallelograms. And you show that opposite sides are parallel. Then by definition, it's a parallelogram. And you show that opposite sides are congruent. Then it is a parallelogram using that converse. Can you show that opposite angles are congruent? Then it's a parallelogram. Can you prove that opposite sides are parallel and congruent? Then it's a parallelogram. And then the diagonals. Now question. Slow down. We still got 2 minutes. Question. If I was proving a quadrilateral is a parallelogram on the coordinate plane, I could do this with 4 slope formulas. All right? I could do this with 4 distance formulas. All right? I actually can't do this with my current formulas. Once you get to pre-calculus, you'd be able to do that. I could do this with 2 slope formulas showing that the slopes are the same and the lines are parallel, and 2 distance formulas. How could I show this? A midpoint formula, and how many midpoint formulas do I have to do? 2. I would do the midpoint of these 2 and the midpoint of these 2. And if I show they're the same, so if you're doing this, use this method in the coordinate plane. It's the easier formula, and you only have to do it twice. Thanks for watching, friends.